Good morning, folks. My name is Aaron Friel, and I'm going to be talking to you folks today about building AI-powered applications here at Pulumi. Um, I want to get started and speak to who the audience for this talk is. I expect that many of you have heard of Pulumi before. That's how you found, of course, this workshop. Um, but there's obviously this growing desire to work in the AI application space and learn from practitioners who are shipping AI applications. So this talk is largely oriented at folks who may have some passing familiarity with Pulumi, may have heard of Pulumi already and kicked the tires on it, but haven't necessarily built anything with AI, generative AI applications, large language models, et cetera, and would like to learn a little bit about what we're doing here at Pulumi with our Pulumi AI and Pulumi Copilot projects, and also some of our learnings from building essentially from zero, starting an AI team here at Pulumi just a little over a year ago. I hope that makes sense to everyone here. Of course, we'll have plenty of opportunities to take Q&A, so I do want to be able to take your questions pretty frequently. I have several slides that are essentially pauses so that I can take questions, because we're going to be going through some fundamentals of AI applications for folks who are not familiar with how these large language models work or how the APIs work. We'll talk a bit about some of the learnings for how we built Pulumi AI. We'll do a demo of Pulumi Copilot, which is our most recent AI product. And then hopefully we'll have plenty of time at the end for Q&A to really talk about how we ship Pulumi Copilot with Pulumi, what considerations there are in building and maintaining AI applications, especially from the perspective of a platform team owner. And hopefully this is a really helpful and educational talk for all of you. So, of course, I have to start and talk a little bit about what Pulumi is for folks who may have come here not knowing at all about Pulumi. Pulumi is an infrastructure as code tool. So what is infrastructure as code? It is a declarative way of specifying what your desired configuration is in a cloud provider. So instead of using something like a API, like Photo 3 and Python, or the Azure REST API, all of these things where you imperatively create resources, or even to go a level below that, to do click operations in your cloud provider, right? Folks use Pulumi and infrastructure as code in order to have consistency between their different environments, to be able to stand up repeatable instances of applications, say from dev to staging, staging to production, or even, we'll talk about later, spinning up personalized or individual like dev stacks for each engineer so that they can operate quickly. What distinguishes Pulumi from other infrastructure as code tools is that you can use the languages, the programming languages and tooling that you're familiar with. So what's really, really special about using Pulumi is if you have a team of machine learning engineers, maybe they would like to be able to get their hands dirty building AI applications, but it is intimidating. You go to the AOS console or any of these cloud providers, there are so many tools and options available. But if they're familiar with using their IDE and their editor, Pulumi works seamlessly with those tools. So you get things like code completion, IntelliSense, inline documentation at your fingertips, and more. We have over 150 cloud providers that we support. Of course, all of the major clouds, Kubernetes, and also some providers that we'll talk about later, like Pinecone, that are relevant for building AI applications. We have an open source and a commercial SaaS offering, so it is free to get started and use. And it's very, very simple to get started with using Pulumi. So talking a little bit more about the different languages you can use. I mentioned Python earlier. We also support JavaScript, TypeScript, Go, Java, YAML, actually a declarative language, and also .NET. A little bit what I just said earlier, being able to use all of your existing tooling. So if you're coming from the Python ecosystem, using tools like MyPy or linters and formatters, all of that technology that you use to keep your code quality high for your application teams will work just as well for your infrastructure as code. And as I said, being able to create reusable infrastructure workflows. So whether it's creating a developer stack every time I create a pull request, or even orchestrating Pulumi so that it is built into your application using our automation API, you have a lot of options for using Pulumi as different points of your stack and your operations for platform engineering. As I said, you can get started with Pulumi for free. We have a free forever plan for individuals. This gives you Pulumi infrastructure as code, secret management. So we'll talk a little bit about that later. Limited updates. There's no sort of limits on your usage. And you can also get started as a team and collaborate with others. So you can share your updates, your secrets and configuration. This is a great way to get started deploying AI applications. So why are we here today? This is why does declarative orchestration matter? The AI landscape is growing extremely quickly. I'm sure all of you are familiar with the blitz of headlines and new product offerings in this space. It is a lot to keep track of. Even if you're just watching one of the major cloud providers, their offerings are evolving quickly. It takes a lot of effort to stay on top of this. And if you are trying to build a production grade application on top of these shifting platforms, it can be a headache just staying on top of, how do I use the right API to do this? How do I make sure that my platform team is shipping my AI application the same way in production as it is in our test environment? So because AI applications often require essentially all of the good fundamentals of building a traditional consumer or front end, full stack application, but also integrating with these AI APIs and new technologies such as vector databases. We really want to be able to simplify that, and Pulumi infrastructure as code is one way we can do that. So how much work does it take to, for example, stand up, say, the first task of setting up an EKS cluster? This is actually just, I think, one page of the AWS documentation for setting up an EKS cluster by hand. There is a absolute mountain of reading that users have to use. And then in addition to this documentation, you might notice that there's actually multiple tools being used here. Users are using the AWS CLI. They might be using EKS Huddle or Control EKS CTL. They might also be required to use kubeconfig or kubectl rather to manage their cluster. All of these steps require multiple tools. You have to learn each of these tools. Wouldn't it be great if there was sort of one simple way to stand up an EKS cluster? And in fact, we do just that by shipping a EKS Pulumi provider. And we can wrangle that complexity down into something that's reproducible, portable, that you can be confident that will work reliably. And these components, like this cluster component, which stands up many, many resources under the hood, you can author yourselves. So as a platform team, you can build sort of your ideal AI stack as a component, and then you can provide that to your other teams in your organization, or share it, online. We of course welcome contributions to our Pulumi registry of providers, and we'll talk actually about a Pinecone reference framework that we have later in this talk. So we can translate all of this manual orchestration of standing up a resource and a cloud provider into, in this case, about 6 lines of code. Pulumi is, of course, today, as we just mentioned, shipping Pulumi AI and Pulumi Copilot. We're not just doing infrastructure as code anymore. We have a history of innovation. So going back to when we were founded in 2017, of course, we launched Pulumi open source, Pulumi 1.0. There's a bit of a gap here. We want to focus on some of our more recent product launches. Pulumi Deployments is our CI/CD orchestration platform. It is an awesome tool for being able to deploy a Pulumi stack reliably. and take advantage of some of the things I mentioned earlier in terms of shipping, say, per pull request developer stacks or per engineer stacks. Pulumi AI and Pulumi Insights launched a little over a year ago. Pulumi-esque or Pulumi Environment Secrets and Configuration shipped last year as well, last fall. And then just 1 month ago, we shipped Pulumi Copilot, which is our first Copilot or chat assistant for all parts of the Pulumi Cloud. As we're building out the Pulumi platform for Pulumi for platform teams vision, we're building more components to help engineers and platform teams like yourselves to work seamlessly across a variety of these areas of the stack, of whether it's building security with policy as code, what we call Pulumi Crossguard, environments and secrets with Pulumi-esque, operators and automation APIs for building out more complex orchestration platforms, or building your own developer portal using our APIs around Pulumi deployments. We have all of these capabilities built into the Pulumi platform, and using the link earlier or signing up at app.pulumi.com, you can try all of these features out. I want to take a brief pause here. I did just talk for about, I think, 10 minutes, and ask if anyone has any questions for just generally about Pulumi, infrastructure as code, or any of the products that I mentioned earlier. So I'm going to give us about a minute or so. If anyone wants to ask any questions in the chat, feel free. I'd also say if there is an area that you'd like me to focus on as I switch gears to talking more about building AI applications, if there's a topic that you'd like me to go a little bit deeper on, or something you're curious about, and it might be relevant to some of the slides that are coming up. I know you haven't seen them yet. Feel free to drop a note about what you're most curious about building AI applications in the chat as well. Would love to see those. I do see a question from Kevin. Is the Pulumi Copilot using compute resources from Azure or AWS? I believe in our documentation, we talk about Pulumi Cloud being deployed on the AWS platform. And we've also, we're using Azure OpenAI services for security, compliance, guardrails, and other aspects of shipping large language model APIs. So sort of the answer is a little bit of both. Traditionally, we've relied on these cloud providers for compliance and security reasons. All right. I'm going to continue on and talk a little bit about building Pulumi AI. So what you can see on the right, this is actually Pulumi AI today, although the interface has been largely the same for a little while. It's stabilized. So it is a chat application built on OpenAI's API. So a little bit of a timeline here. In March 2023, OpenAI opened up the GPT 3.5 API. This was a watershed moment for the industry, I think, as we all suddenly were able to build applications that mirrored the functionality of the incredibly popular ChatGPT, the rising in popularity ChatGPT application. We shipped Pulumi AI on April 17th, so about 6 weeks later, and then we learned how to ship AI applications. This is actually, I think we were all sort of in the same boat at this time of, okay, what is this technology? Can we use it? Is it useful for our users and our customers? Then we shipped something, and then we had to learn exactly how to operationalize maintaining this thing, keeping it up to date, maybe changing out some of the fundamentals, updating the UI, as you can see in the screenshot, supporting things like GPT-4 or GPT-4o. So definitely, there was a lot of sort of shipping quickly and then learning from the consequences of deploying and actually having a production being used by a lot of folks. I think to date we've had, I think it's close to 1 million now prompts submitted to Pulumi AI. I'd actually have to double check on that number, but it's been a pretty steady pace of users for a good deal of time now. We've also we had to rapidly iterate in the sort of the weeks that followed launching to change Pulumi AI from being merely a GPT wrapper to a RAG application. And so you might ask yourself, wait, what's RAG? Let's take a step back and talk a little bit about AI APIs. So if you're already familiar with chat completion APIs or OpenAI's API, this might be a little bit reductive, but it is worth talking about for all the folks in the audience what exactly a prompt is like, what RAG is, or retrieval augmented generation, and why it's important for shipping AI applications. So this is effectively everyone's first AI app. It's this was so many of those wrappers that were shipped in the first weeks after GPT 3.5 launched. They were something like a static site with an AI API. Maybe they were using some front-end framework for that. And then if they were a good application, if they were working really, really well and people really enjoyed using them, they were almost certainly using some form of streaming, where they're using the streaming API from OpenAI. And that way they got that seamless, very quick response from the server. And it sort of just flowed the text in as the user was watching. This will come up later when we're talking about Copilot, but this was our first pass at building an AI application. How did this work? The first wrapper that we shipped for Pulumi AI, like everyone else, we used a system prompt. It's important to understand how these chat completion APIs operate. So there are typically 3 participants that are labeled. There's a system, there's a user, and a assistant. The system prompt is used to guide the generation of the text that follows. The models are tuned to follow the guardrails that are established in the system prompt, which effectively sets the identity for the assistant, but also what are sort of the rules of engagement in this conversation. It's important also to know that these models, typically, if you're using these APIs, they do not have a memory. Every API call that you send to, whether it's OpenAI's API or Anthropic Claude, Bedrock, Azure OpenAI, if they're using a completion API, you're responsible in your service for including the entire conversation. This has important cost considerations as well. The cost grows essentially quadratically as the conversation gets longer. And that's actually another aspect here where we'll talk about with RAG. So a user comes in, says, make me an EKS cluster, and then we send this prompt off to a AI service. Then the assistant says, sure, here's how to write an EKS cluster. If we're doing a great consumer chat application, then this will nicely stream in. The user will probably wait between half a second and 2 seconds to see that first word appear on the screen. If we're not using something like streaming, the experience can be measurably worse. We've seen initially when we launched GPT 3.5 support, we could see up to 30 seconds to a minute of latency before the final token arrived. And that's because we were generating fairly long, complex pieces of code in addition to the text response. And so it was especially important for us to have that great time to first token. We'll talk about measuring Pulumi AI later as well. So what is RAG? Retrieval augmented generation, of course, starts with the user story. As an AI engineer, I want to answer the user's questions. And here's what I have. What I have is a message from the user, that question, make me an EKS cluster. And I might have a database, this knowledge base of facts and resources that either it's API documentation that we have, pure just text documentation on our website, But we want to be able to use this knowledge base in some way. The challenge, though, is how do we find the right document for a user's question when the question might be very different than the answer? An example of that is if I want to store files on AWS, I might ask Pulumi AI, how do I store files on AWS? There's a lot of different ways to do that, but the answers are, of course, things like AOS S3 bucket. That is one of our resources for storing files. There's quite a few other options, but that answer doesn't resemble the question. However, if we index not just, say, that specific answer, that AOS S3 bucket resource name, but we also index the documentation related to that. We might have some descriptions, some fields in that resource, other properties that we can then include in that index, but then we use something called an embedding. And that embedding reduces down this large document into a vector that we can search. So again, we have this user asking a question, make me an EKS cluster. We take this embedding that we generate from the user's question, and we take also all of our answers that we put into a vector index or database, and we try to find similarities between the two. So the vector embedding, it is a learned representation of a piece of text. So applying the same technology that large language models use to understand sort of what is the meaning of what I'm looking at, we can take these large vectors, compare them with one another, and find similar records. So even though the exact words store files in AWS may not be present, concepts like Amazon Web Services, files might be similar between a resource and a user's question. So that was the first step towards building a RAG application as opposed to a GPT wrapper was take our existing providers. We have over 150 of these, over 100,000 resources, and to persist them into a vector database. Then we generate a query, we run that query, and we obtain the resources that might be relevant to answering that user's question. We then put in another system prompt. This could also be an assistant prompt. There's a lot of different ways to sort of decide how to thread these conversations. But we inject this additional context into the call saying, these are the relevant resources to the user's question. Use these to answer their question. By doing this, we can ground the large language model in knowledge that we've verified, right? And not only that, we can actually prompt the model to cite its sources. So if you use Pulumi AI today and you ask it to create an S3 bucket or do anything like that, it should cite its sources. It should link back to documentation that's relevant. And that's because you don't see the system prompt, but between your question and the assistant's response, what we've done is we've added a large amount of context on what's possibly relevant to the user question. This is really important for ensuring that we keep the code quality high with Pulumi AI. We found that for some of our languages, we are up to 10 times more likely to generate working code on the first pass. That's really important. And even when we don't generate working code, because the models are, again, not perfect, we still end up generating code that is very, very close to. Like if a user copied it into their ID, there's often fewer than a couple syntax errors or something like that they need to repair in order to be able to run that application. We'll talk a little bit later about actually maintaining AI applications and how we measure that. But I want to take a brief pause again. If anyone has any questions about using chat completion APIs or LLM APIs, I want to give space for people to ask that in the chat. Seeing no questions, we'll keep going. So let's talk a little bit about some of our learnings from shipping Pulumi AI. I think the first thing is you want to experiment early and often. Actually, I do see a question that just came in, and I think it disappeared. Um, Whoever asked that question, feel free to ask your question again. Um, I'm not sure why it disappeared from my view. So yeah, learning from shipping Pulumi AI, you definitely want to get your team set up with developer APIs with one or more of these major providers. So OpenAI and Anthropic are leading large language model offerings. They have respectively GPT-4o and Anthropic's Claude model. Really, really astounding models. But you can also access really high quality models from AWS through their Bedrock system, through Azure, and Azure has both a variety of open source models and Azure OpenAI offerings. And Google Cloud has Gemini as a model, and then they also have an open source model called Gemma. Um, so you're going to want to familiarize yourself with one or more of these players. If you're just getting started, I find that it is easiest to get started with the vendors on the left, OpenAI and Anthropic. Although if you are already using one of these major cloud providers, these all have great getting started guides for using their models. But I really particularly like the developer tools, or the Workbench in Anthropic, or the developer playground in OpenAI, which lets you experiment with these APIs and understand how they work, change some of the parameters, which is interesting. Um, yeah, and I would think it's also really important to establish what are you trying to build early on. If you're building a generative AI API or an AI augmentation to an existing product, you may not be latency sensitive. And that has a huge consideration for how you build your AI application. We were building a chat application, though, something that a user would type in and expect to see a fairly prompt response. And pretty consistently, whether it was our users or internal users, our users would compare ourselves to ChatGPT. Uh, this is just sort of a fact of life here in this area, is that no matter what you build, no matter how much you test and evaluate it, your users are going to be comparing your application to these general purpose chat apps like ChatGPT, Claude, both of which are free for users, or Gemini on Google's platform. So just keep in mind that you are competing against a pretty well-developed product, sort of from the start if you're building a chat app. That said, you don't have to start from scratch, sort of like we did. If you are building an application today, there are a wealth of abstractions and tools to get started. We really had to do kind of everything from zero, whether it was building streaming parsers and dealing with rapidly changing APIs from providers, trying to roll our own vector database and sort of get our handle on how exactly do we store documents about our providers to be effective. However, there are now a wide variety of abstractions over these. I want to call out specifically LangChain and Pinecone. We have some reference architectures and blog posts about how to use LangChain and LangServe. We also have reference architecture with Pinecone. We'll talk about that in the next slide. But there are also other SDKs and toolkits, the Vercel AI SDK for Node.js, Llama Index. Azure AI Search is a vector database and search product, and it's integrated with the AI offerings there. AOS has Bedrock knowledge bases. There's a lot of tools that allow you to abstract away sort of building that vector database. Along those lines, a couple slides shout out our Pinecone integration here. We have a Pinecone provider. This is an example of creating a vector index in Pinecone. You'll notice here, again, it's declarative state configuration. We're able to declare this Pinecone index. It does work with Pinecone serverless as well. And we're able to then stand up as many of these indices as we need, maybe per developer, per team, or per product. We have this Pinecone and EOS reference architecture, which I will drop in the chat. Drop this here. In this reference architecture, it stands up a variety of services for you. It stands up a indexing service, a web application that supports streaming and chat application sort of behaviors, and is a great way to get started if you're just really want to just go from zero to having a working RAG application using generative AI. This is probably the easiest way to get started. It takes maybe about 10 to 15 minutes. I'm not going to go through the whole process here, but essentially sign up for Pinecone, sign up for Pulumi, configure a few keys, and run Pulumi up, and you will have a working RAG application. I do actually, before I move on to this next slide, I do want to talk a little bit about how do you choose sort of between all those frameworks. One thing I recommend builders do is choose frameworks that align with the current languages and skills of your teams. I know it sounds straightforward, but I've heard from numerous other practitioners where they had an existing team, maybe a team of Go engineers, and they wanted to get their, build an AI application in Go. There's unfortunately, there's not as many frameworks for writing AI applications in Go. A lot of these frameworks are Python or Node.js. So for example, if you're on Node, the Vercel AI SDK has adapters for working with all of the AI large language models that I mentioned earlier. If you're using Python, the LangChain framework has adapters for all of these models and all of these vector databases. It's really great to be able to start with a common API for all of these things because you will want to experiment and find out what works really well, what tests well and passes evals that provides the right answers for your users. Speaking of course, choosing the right framework, choosing a model can be its own challenge. How do we choose a large language model? How do we choose an embedding model? How do we choose our prompts? As many AI engineers, and I'm quoting the inimitable Simon Willison here, is it just vibes? And it can feel like that at times because we're dealing with chat applications or non-deterministic text output, we can't write conventional tests and assertions. How do we solve for this? We run evals. Evals are a term that essentially means a test where the evaluation or the rubric for the test is either a person or a large language model itself. You're not writing an assertion that says this response equals some string. You're saying, take this output from a large language model, maybe run a query through it, and then assert that the result says there are between 500 and 1,000 buckets. Not necessarily a specific number. That is an example of an eval that we have in our system, is we have a query, how many S3 buckets do we have? Answer should be between 500 and 1,000, and it should mention bucket in the response. The eval is essentially text. Another way to choose a model is there's something called the LM sys arena. These folks have built effectively a dueling battleground for models. So the LM sys arena involves users being able to submit prompts or take prompts that are from the system, send them to two models that the user cannot see which those models are, and then rate whichever response feels best to them. Using this arena, we can see how these models stack up and compare to one another. So I think the short answer is if you're trying to choose a model and you're on Azure or you're using OpenAI, use GPT-4o. That is just the straightforward correct answer for today. If you're using Anthropic or you're using AWS, which Bedrock has a Anthropic offering, use Claude 3.5. That's just the right answer for you. And if you're using Google Cloud Platform, use Gemini. I think that these are effectively the best models today, although that can, of course, change pretty quickly. So keep on top of these as they change. And I think that's why it's important to be able to use these frameworks that adapt to the different APIs that each of these has. Now, in terms of measuring quality, we have a bit of an advantage here at Pulumi where we are able to use binary criteria to evaluate the quality of our responses. In addition to our evals, which say that the response has to include, links to documentation, we have a funnel where we can evaluate first, does the code syntactically make sense? Does it pass, say, the syntax checker of that language or a linter? Does it compile and type check as well? Then does it Pulumi preview? Can we actually run the Pulumi process through that code? And lastly, and we've only largely done this for, of course, our internal generated applications, can we actually Pulumi up it? Can we actually deploy that code? So while the output of a large language model may be non-deterministic, if you are able to find criteria like this that are binary, those are solid gold. They are going to be the best way for you to make sure that you don't regress in shipping new instances of your application. Failing being able to find these criteria, you're going to want to find a test harness. So for folks who are used to the different testing tools for languages, whether it's ViTest and Jest, different Python testing tools like PyTest, there's sort of this new generation of eval frameworks. I've listed a few actually here. LangChain has a eval framework, I think, called LangSmith. LM eval is a popular library for Python, and PromptFoo is a popular library for TypeScript and Node.js. And these allow you to write these sort of rubrics where a large language model prompt is run through your system, and then a large language model prompt evaluates whether or not the result meets your criteria. Another thing to note here is you should accept a threshold and not perfection. We try to make sure that, for example, on all of the, when we launched Pulumi Copilot, we evaluate ourselves against a list of about 20 or so questions that we knew that we absolutely had to pass on launch day. And we did not always get 100% score on that on every eval that we ran. Sometimes it was 95%, sometimes it was 90%. We tried to aim for 100%, of course, but if we blocked shipping on reaching that and stabilizing at 100% success rate, I don't think we would have been able to ship. So you do have to accept adding more evals is better. Make sure that you capture your most important user stories in these evals. Talk about that with Copilot, and make sure that you're measuring frequently. Another factor for shipping AI applications is measuring performance. Your users are going to be particularly sensitive to when your application starts feeling slow. And you can actually see there's a bit of a spike here in our in this unlabeled. I wasn't sure what I would be able to share in this talk, but this is a real performance graph from Pulumi AI. However, of course, I've removed what some of the data is, but you can see there was a performance regression where we slowed down, and users did give us feedback about that. There's really two important measurements that you're going to be caring about. First is time to first token. That is how long it takes for the user to first see that piece of text that they see in the response. But it's especially important to recognize that if you're building a RAG application, your processes that build, query that database, produce the prompt in order to put that into the context window, that's going to contribute to your time to first token as well. And we've actually seen at times that sometimes we are faster than the large language model. Sometimes we are significantly slower. It's very easy to sort of miss out on that. So you do want to measure these intervals distinctly. And we do that with every prompt that we generate. Time per output token, or TPOT, or time between token, same term. That's going to be how quickly the model responds. Once you've exceeded, I think, roughly 15 to 20 tokens per second, which is the inverse of time between token, you start to exceed sort of the speed at which most people will read. And all of the models that I mentioned earlier that I recommend are going to be much faster at emitting tokens than users, at least barring some maybe speed readers that you might have, are going to be able to read. But then the important consideration is, of course, the latency of how long does it take to actually generate a full response. So latency is going to be your time to first token, plus, of course, the number of tokens times your time between token. So these are going to be the factors that your users are going to be comparing you against, especially we found that after shipping RAG in the very early days, we didn't have a very optimal implementation. And so users gave us feedback that even though Pulumi AI was more precise by all measurements that we had, it felt worse. And that goes back to your users are going to compare your application to ChatGPT. The same user typing the same prompt into ChatGPT or saying, you know, that same prompt plus write me a Pulumi program, they would say, that feels better, even if your actual output was better, was more accurate using your system. So just something to keep in mind. Along the same lines of keeping abreast of all of these changes in the AI ecosystem. This is a kind of a confusing graph to read. On the y-axis, we have price and its log scale. So at the top end, we have $100 per million tokens, and at the bottom, we have 10 cents per million tokens. In the gray, we've got all of the models that were released in 2022, which are effectively OpenAI's models. There are some other models that aren't included here, but GPT-3 really established sort of this first wave of higher quality models that could answer questions. On the x-axis, we're measuring MMLU accuracy. So I have to give a shout out to Simon Willison, who presented a slide like this at the World AI Engineer Conference just a few weeks ago, and also Karina Nguyen, who collected this information and has a great blog post here as well. And she compiled these graphs. So what is MMLU? MMLU is a benchmark. Essentially, if you think back to doing standardized tests, multiple choice questions, MMLU is effectively a large battery of knowledge questions across a really wide variety of domains. This benchmark has a few problems. One of which is that there's definitely some consideration that maybe some of these models might be contaminated, might have actually inadvertently trained on the MMLU battery. There's a lot of effort taken by these model providers to ensure they don't, because if these models are contaminated by knowing essentially the answers, by getting slipped the answers during training, then the benchmarks become less meaningful. And that's actually why I think the LM Arena benchmark is probably a better measure. But we can see that MMLU accuracy has been progressing, so up towards nearly 100% success rate on this benchmark with GPT-4 in the top right corner. And so all of these 2022 models are effectively dominated. They're behind the Pareto frontier of the 2023 models that are in orange. You should never use GPT-3 or GPT 3.5 if you are in that quadrant, that top left quadrant, and you're using those models, or you're not impressed with the quality of your AI. You are well behind where the model's capabilities currently are. And you'll actually notice too that all of these 2023 models are effectively dominated by the models that have shipped in 2024, which for the same price are more accurate, or for the same accuracy, much cheaper, sometimes 100 times cheaper. So again, if you are building something using GPT 3.5, or if that was your impression that you got maybe sometime last year, you opened up ChatGPT and you thought, what is the big deal? You were probably using, frankly, an already outdated model, because that's what was offered via these chat applications. You're going to have a lot more success building on GPT 4.0, GPT 4.5, Claude Sonnet. And actually, this graph is missing a few models. GPT 4.0 and Claude 3.5 Sonnet actually move even a little bit further down into the right. So just spoke a little bit about a variety of models and frameworks. I want to give us a little bit more time for Q&A. Any questions you have about using these frameworks, or comparing models, writing evals, any questions like that, I'm happy to take right now. And I'll take you again about a minute here for any questions. Seeing no questions coming in, but definitely I'm welcome to take any questions as we move on. We get to after the next few slides here. So I want to talk next about building Pulumi Copilot. So Pulumi Copilot launched last month. It is a substantial upgrade over Pulumi AI. And we've enabled Pulumi AI to answer questions about insights, that is the resources that users have, using the Pulumi Cloud's REST API, actually being able to answer questions about a user's organization and other metadata that they have. It's still able to author code and deploy programs. And we're building more skills as we go. So I do want to take a moment to do a little bit of a demo of what we've got in Pulumi Copilot. Give me a second to sign in. All right, and we'll then switch my screen share. All right, screen share again. There we go. All right. You should now be able to see the Pulumi Cloud console. I've got Copilot open and I am in my Pulumi organization. So the Pulumi Copilot application sort of lives in the bottom right corner here. We built a sort of hovering chat application integration, similar to a lot of other tools that are building like chat applications into websites. We have a, sorry, I'm seeing that my network may be unstable. My stream might be lagging. Okay, looks like that's gone. We do prompt the user with a few possible questions. And so I can ask questions that are that might involve deep details about the Pulumi organization. So for example, I can ask, what AWS account does VPC? And I'm going to paste in some ID. Maybe I've seen it in my logs. I'm going to ask this question. And you're going to see actually Pulumi AI, or Pulumi Copilot rather here, starts giving users feedback pretty quickly after they ask their question. It's going to tell users that they're asking for a skill or that it's executing a skill. And here it's actually running a query against our Pulumi resource search. So that's resource search over here on the left. And so it's run this query. I can paste this in here and see exactly the same result and find this VPC in our testing stack in Pulumi service. And so it provides me some additional information here that gives me a last modified. This is, of course, chosen by the language model itself. We have a few other demos here I can do. Let's see here. One will come up in a later question here. I'm going to start a new conversation. So I'm asking a question in Spanish. I will not try to, I'm not a native Spanish speaker, but this is actually one of our evals, is to ask this question and make sure that Copilot answers in the language that the user asks it in. And so this was from an internal Pulumi employee, and they asked this question. Of course, we thought we weren't doing as well as we should on this question, and we added it to our evals. So yeah, this is going to be, I think, a search for all of our S3 buckets. And so using the Pulumi Copilot integration, we can also ask things like, who are the admins of my org? So those are both resource search questions. I can also ask questions that might use the Pulumi Cloud REST API and ask questions that anything that you could do using the API. And so in this case, we're seeing that it's going to be executing a GET against the Pulumi org, and it's going to be getting all of our members. In some cases, though, the model is having to digest quite a lot of text here. So we're actually using the model to summarize the output of these commands. Some of these APIs might be fairly verbose and could stand to be optimized, but that is an aspect to when building these skill-based or assistant-like applications. And actually, gonna give this a piece of feedback here. We didn't respond. We've been actually trying to find a repro for this. So let me try this again. Who are the admins of my org? It's actually kind of an interesting aspect of building an assistant using what's called the tool calling or function calling API. One of the tools that it has access to is the reply tool, but sometimes it will choose not to invoke it. You're kind of at the mercy of these large language models in some of these cases. I think this is making the same API call, and actually this is a good call out for us to maybe look at maybe adding an eval here to make sure that we're succeeding on this. I'm actually going to, I'll stop screen share and switch back to my presentation. I do want to talk a little bit more about shipping Pulumi Copilot and how we've done that using, oh, here we go. So we've got some admins in our organization. So yeah, sort of the inconsistency of using large language models. In another sort of woe to using live demos. Going back to the presentation. I did see a question actually in here about benchmarking, publishing benchmark information. No, we don't publish benchmark info on accuracy and performance costs. There are some. I'm dropping the name of it, but there is a tool, and I can actually get back to you if you want to send me an email. There is a service that does benchmarking regularly of large language models and measures cost per performance, cost per token, things like that. Also shows things like latency, so you can compare the models between different vendors in that aspect if you're concerned about speed of throughput or other things. But yeah, I want to get back to talking about shipping Pulumi Copilot. So how did we build Pulumi Copilot? How did we decide what evals to write and how to advertise and talk about Pulumi Copilot at launch? Well, the way we did it is actually internally. We shipped this for all of our internal users. But what you saw was Pulumi Copilot had some predefined prompts, some suggested prompts of what to ask. But when we shipped it for internal users, we did not do that. We gave them essentially a text box. We told them that Pulumi Copilot can do anything you can imagine. Of course, this wasn't strictly speaking true, but we wanted to get real world questions that users might ask, assuming that Copilot could answer them. We then took those questions, and every time a user told us, it didn't answer how I wanted to, or it didn't use the information that I think it should have had access to. We turned those questions into evals and assertions. So using that example I just gave, asking a question in Spanish, verifying that the answer came in Spanish. The answer was between 500 and 1,000. Or the question I asked after that, how many admins do I have in my organization? Well, it should at least list Joe, our founder, right? Like those are evals that we can write. And so we're not necessarily testing specific strings, although I guess Joe would be one of those, but we can also test that there's a certain number of responses. Sometimes the model might not list all of the admins because there are a number of them. Sometimes it might list just say the first 5 or maybe the oldest 5, the original 5. So being able to write conditional rubrics was really important for assessing the quality of Pulumi Copilot. Lastly, we shipped Pulumi Copilot with Pulumi. So we have been, as a team, this should be no surprise, as an AI team, we're early adopters. Of course, we use Pulumi IAC for deploying and shipping Pulumi Copilot. And this actually encompasses everything from building the container using our Docker build provider to shipping the container image using a tool like ECR or a Docker Hub, and then actually using that container image in a production application. So it's all defined in one program, one Pulumi up. This makes onboarding and spinning up a dev stack, for example, very simple. Users able to essentially open up clonar directory internally and run Pulumi up, and it should just work. We make that work by continuously testing with Pulumi deployments. Pulumi deployments is our CI/CD product, so every time I create a pull request against Pulumi AI or Pulumi Copilot, it creates a developer stack for me that I can then test. This is really great because when you're trying to work on improving the performance of an eval, it can be helpful just to be able to spin that up and have an instance of the application with different prompting or different tools available to it, be able to share that with other engineers. We're using Pulumi-esque. As part of shipping Pulumi Copilot, we've had to manage a large number of API keys, endpoints, and credentials, and we use Pulumi-esque as well, so that way every user who opens up our stack, and we're using actually the dir-env integration. So we have a blog post on using Pulumi-esque with dir-env, and so when a user has dir-env installed and they're part of our Pulumi organization, when they even just cd into the directory that Pulumi AI is in, their console lights up and has credentials and access to a OpenAI API key, Anthropic API key, various Azure OpenAI endpoints. This has made it very easy for us to enable users to experiment with all of these tools. And lastly, of course, this is quite fun, is having built Pulumi AI a year ago, we of course used Pulumi AI when authoring Pulumi code. This is actually, I think, one of the areas where I think infrastructure as code is particularly amenable to authoring with large language models. Unlike imperative code, where you have to be sort of always aware of the state of the application or state of your cloud provider before, as you're, say, updating a resource, deleting a resource, making some sort of change. As a declarative infrastructure tool, the AI model only has to know how to generate the desired state or the desired code. And these AI models are actually extensively trained on authoring code, especially authoring very popular languages, Python, TypeScript, Go, etc. And so we've actually found much higher success rates at using AI to generate Node.js code than YAML or other infrastructure as code languages from our competitors. So by using very, very common tools, we benefit from the inertia and the pre-training that these models have had over all of that code in the world. So this was, I think, kind of a quick tour of our journey towards shipping Pulumi AI and Pulumi Copilot. I do want to open up now the floor to any final Q&A that users might have. And it looks like we have plenty of time for me to answer any questions about shipping AI applications at Pulumi. I see Bill in the chat ask a question. Is there any independent school that imparts the same unbiased info here for the cynics among us, like our bosses? That's a great question. I feel like we are so early here that my hunch is that you're going to have to sort of listen to the builders. Of course, don't take my word for it. Go find folks like Simon Willison, who is fairly independent. His blog posts on AI and large language model applications, his blog is fantastic. He's also the author of the LLM Python program, so it's a great way for running Python programs or running open source and API-driven models from your command line. And he probably more than anyone else has just experimented with all of the different models that are out there. I think in terms of evaluating things like vector databases and other products, there are open source benchmarks for comparing Pinecone to other products in the space, whether you're using something like Postgres and pgvector or a wide variety of other open source offerings. I think Pinecone, it feels very confident, and they have some blog posts showing, and I think they've actually contributed some of their own benchmarks to those sites as well, showing their performance and speed and accuracy or recall as it's measured. Yeah, I think the way that I stay on top of information here is sort of, I guess I would say it's a little unfortunate because there aren't sort of trusted independent authorities. There's sources like Hacker News and Reddit, staying on top of the LLM and AI communities that are there, and of course reading blog posts from builders like Simon Willison, Andrej Karpathy, who has since left OpenAI. He's more interested in the low-level fundamentals of building these models and has talked a lot about building sort of GPT-2 from scratch. And then I would also call out Andrew Ng, a professor who's worked in the AI space for a very long time and is an expert in this area. Talks a lot about in recent lectures he's given about agents and sort of the future of language models. Those are just a few of the sources that I use that might be a little bit more independent than maybe me. I see also a question from, I hope I got this right, Iqbal. Does Pulumi publish benchmark info on accuracy, and performance, and cost? We do not provide benchmark information on accuracy, and performance, and cost ourselves. Like I think I mentioned earlier, I think I saw this question earlier, there are some websites out there that compare models by cost and throughput, or scores by like the MMLU score that I saw earlier. Yeah, I think I don't think we're going to be getting into the game of publishing sort of cost and performance benchmarks, but I will say that as a team, Claude 3.5 Sonnet, I think, was launched, I want to say 5 weeks ago or so. And we're of course already looking at it. Is it a better model for our users than GPT 4.0? We always want to make sure that we're providing the best experience. So the best thing I can recommend for folks is to try out different models and see what works best. All right. I'm going to leave the floor open for another few minutes here if there's any questions. And then if not, then we can adjourn a little early. No, thank you, Paul, for the thanks there. Thanks everyone for attending. I'm not seeing any more questions coming in. If you do have a last second question, just type something into the chat to let me know to pause a little bit and wait. But if no one else has any more questions, I think we're going to adjourn. Thanks everyone for attending. Of course, feel free to reach out to me. Feel free to reach out to Pulumi and ask. Oh, we do have one last question here. Trying the tools out can be delaying and expensive. Bill Kleinbecker asks, yeah, it can be delaying and expensive. Is there an industry effort to get it done? I guess, Bill, I'd have to ask, is your question that is there like an industry effort to sort of build like a best tool or a common platform, or to sort of do a common measurement or benchmarking? I'm not sure exactly what you mean by effort to get it done. Can you elaborate? I see. So your question is the news of folks bringing up the issue of hallucinations. So I think there's a couple questions here. Trying out new tools can be fairly costly, and I think trying to find a model that doesn't hallucinate, I think I'm not confident myself as a practitioner and someone who's used these tools for over a year now, that we're ever going to be able to truly eliminate things like hallucinations. And in terms of trying out different tools, certainly trying to use multiple frameworks. I think I would not suggest that people do that. If you're in the Node.js ecosystem, I really strongly recommend the Vercel AI SDK as a great way to get started. And that gives you, I think I mentioned earlier, adapters for all the major large language models. That way you're not rewriting, if you want to switch from using OpenAI to Anthropic to AWS Bedrock, you're not rewriting that sort of low-level code to do that each time. Um, my hearty recommendation is choose one of these frameworks. I should also shout out LangChain, who we worked with on a few things here at Pulumi. For the Python ecosystem, another great framework for getting started using or building AI applications. Once you've sort of settled into using a framework, obviously your inertia to switch is going to be a lot higher. But fortunately, these tools have pretty rapidly added support for new APIs and new platforms. And of course, with tools like with platforms like AWS Bedrock or Azure's API, you're able to get a fairly consistent API across a variety of their services. And so you're able to switch models without such a high barrier to evaluation. In terms of industry effort to get it done, in terms of addressing hallucinations, it's the models essentially, they need to be sort of creative in order to be able to answer questions. I'm not sure exactly how we can either stop the, address the conversation, the elephant in the room that hallucinations or creativity is essentially a big part of why these models sort of work and why people find value in them. Being able to speculate or talk about something that maybe isn't completely grounded in what's in their current prompt based on their pre-training. But I will say that if you're using more current models like GPT-4o, Sonnet, and Gemini, the system prompt is much, much more effective than it has been in the past in being able to guide the output of the LM to say, I don't know, when asked a question that it doesn't know the answer to, or to ensure that it stays within some guardrails. I think responsibility in AI is also very important. All of the different providers that I mentioned have things like moderation APIs as well. And we didn't talk a lot about that. Our use case for Copilot and Pulumi AI is primarily around authoring code, something that these models do very, very well. And if you're building a more general purpose application, you're probably going to be very keenly interested in establishing guardrails for the model's output or the prompt's input. Certainly, since Pulumi AI is a public and anonymously accessible text box on the internet, we've certainly seen a variety of different user inputs, and that is a factor for us, of course, in moderating sort of the quality of the data that we get from users of Pulumi AI. But all of these factors, I think, are getting significantly better. I think we've publicly talked about how we use Azure OpenAI for Copilot today, and they have a great moderation API that's actually built into their model service. And so you're able to get real-time feedback as you're calling the LLM on, is this a prompt injection? Is this some sort of content that you might want to forbid or block, some other things like that. So those are all really useful tools. All right. If there are no more questions, and I haven't seen any since Bill asked his, I want to say again, thank you all for coming. Yeah, Bill asks or says, suggesting for the US a group in the SFO area. I do think actually there is an effort from the AI companies to educate, lobby, talk to the political types. But yeah, I think that there's definitely a lot of interest to make sure that language models are being done responsibly, that that we're working sort of for the betterment of everyone and not for a particular. I know that Anthropic has talked a lot about in their most recent statements about um, building a character for Claude that is objective, grounded, isn't sort of putting their thumb on the scale in particular in one way or another. Really important consideration. So definitely, I think there's a lot of folks that are already working on things like this, Bill. But I do want to say thanks to everyone for joining. I appreciate your time, appreciate listening to me talk about AI at Pulumi. And I hope that you can go out and build an AI application. I hope that in the coming year, I'm going to be using an application that you wrote. And if you do, feel free to reach out to us. If you have any questions about using Pulumi AI or Copilot, of course, feel free to reach out to Pulumi and we'll try to help you. Thanks so much for your time, everyone. Have a great day.